So we started the day today, and it seemed like a normal average Friday, but here we are at 5 o'clock, and we're all I/O experts. So we're writing big files, we're storing good data, we're going to come back and analyze it later, and we've learned how to do that. But the question is, now you have these big files you've been generated, and you want to do wonderful things with them, what now? So we're going to talk a little bit about data management tools. The hardest thing by far when using HPC I/O is just getting efficient access. So that's why we spent most of the day on it. But you also need to think about stewardship a little bit once you've created your data. And there's two particular things that usually come to mind with this. One is archiving. So if you're trying to protect your data to make sure it doesn't get lost, or you want to save it for future use long term, you can't keep it on the file system forever. Someone's going to get grumpy with you. Or simply, if you can't fit all your data on the system, you have a quota, a fixed amount of data that you can store, and maybe you need just a little bit more. Or also there's transferring to other facilities, maybe even to other file systems in the same facility, but definitely if you're trying to transfer to a different compute facility entirely, you need a way to do that. So we'll talk about archiving first. All of the DOE compute facilities and most of the other large ones as well and other organizations have large tape backup systems for their HPC compute facilities. And this picture here is from the one at NERSC a few years back. And I don't know about you guys, but when I see this, I think of that last scene of Raiders of the Lost Ark where there's the warehouse and they're taking things back there. So I always wonder what mysterious secrets are in these tapes when I see this picture. But there's dozens of controllers that can read and write a lot of tapes at the same time, hundreds of petabytes of capacity, so it's far larger than the file systems even. And they have robots that run around and pull the tapes out and load them for you. So this is complicated, and it looks like it could be difficult to use, but there's a lot of good news here. I'm not an HPSS expert, but I don't have to be to tell you about it because it's actually pretty easy to use. But this is HPSS is kind of the standard thing that a lot of the big sites use to organize their tapes and make it easy to store and retrieve backups. So a little bit about what HPSS is. So it was actually developed mostly by IBM, but with input from all the DOE laboratories. So it wasn't just a product that was kind of made in a vacuum and sold. It was kind of co-designed or designed in a collaboration. And like I was saying before, it organizes lots of tape devices, and it's meant for HPC use cases, so it scales big. And the particular technologies that are involved, there's generally a database in there that indexes what's in all those tapes. And there's usually a big disk array that can cache access. You don't literally have to wait for a tape or a tape robot to put data in there. It can cache for a little bit and then get pushed out. And this diagram I took from the HPSS website, but it kind of gives you a flavor of all the things that can hook into HPSS. This includes things like Globus, which we'll talk about in a minute. Of course, it hooks up to the compute node, well, not the compute nodes, but the login nodes and other facilities at HPC centers. And, it can hook into Swift, S3, all these different things. So it's really got a lot of capability. So if you want to know how to use it, Google HPSS and NERSC, or HPSS and ALCF, or HPSS and ORNL, and you'll find the user's guides that tell you how a particular site's HPSS system works. They may list a few different tools. There's more than one command line tool for interacting with it. The easiest one, if you just want to learn how it works and try some things out, is HSI. On some systems, you might have to run module load HSI to get it in your path. And once you have HSI, there's two ways you can use it. You can just run HSI by itself, and you get a terminal where you can type commands to store and retrieve files. You can also give it command line arguments if you want to run it in a script. So if you have as just part of your workflow, things you do day to day, if you want to automate some things, you can do that too. So I don't have a live demo, but we don't really need it. It's really this simple. You can module load HSI, run HSI, and then you get a sort of a prompt here where you can run commands. And if you want to put a file in the tape archive, you type put in the name of the file. You can do an ls to list the files you've put in there. And that's really about it. You can give a -R to the put command if you want to put a whole subdirectory in there. Surprisingly enough, Git is the thing that pulls it back out into your file system for you. One thing, actually two things I'll point out. One is that if you're using an ALCF guest account, you're not going to be able to play with this today, I'm afraid, because understandably they don't want temporary accounts to be putting things indefinitely into the tape archive. If you have a normal ALCF account or account at another center that has HPSS, you can try it. Some of the facilities don't turn it on automatically for all users, so if you go to run HSI and it says, sorry, you can't do that, just email your support and say, I would like to use the tape archive. The second thing I wanted to talk about is transferring data. So this isn't just literally copying files from one place to another, but sometimes it's publishing data or making data available so that your collaborators at other places can get to it. There's a lot of hardware capability for this. For the DOE, we have something called the Earth Sciences Network, or ESNet is what it's usually called. And what ESNet is, this is a picture of some of the big links in ESNet, but it's a dedicated fiber optic network that connects all the big compute facilities. So if you go to copy something from Argonne to Lawrence Berkeley, it's not going to go over the general internet where everybody's Netflix traffic is. It has its own connected links to go there. And but it's transparent. You don't do anything special to use this network. You just copy things from one place to another, and it goes on that network. But if you use the usual things you're used to on your laptop or workstation, like SCP or FTP, it's going to be real slow. These links are fast. They're many gigabytes per second. Your file system is fast. It can do hundreds of gigabytes, if not a terabyte a second. And if you're just going to have one little program kind of reading little bits and throwing it as fast as it can, you're wasting a lot of capability there. So there's a solution for this too. It's called Globus. And Globus, you can think of it as a data management service if you want to transfer data from place to place, or if you want to share some files or publish some files. I took this graphic from their webpage. They have a tremendous number of users, and people are transferring many terabytes of data per day. And it's hooked up to a lot of institutions. And this is supported out of a nonprofit organization out of University of Chicago. And some of you may be familiar with Globus from a long time ago, which is sort of a grid computing framework, but it's kind of evolved more into this data management service. But Globus can be really easy to use. There's a web interface that you can log in, and it's easy to kind of browse around and click on things and learn how to use it. Like HPSS, you do not have to use it interactively. There's a variety of scriptable APIs that you can use if you want to have some programmatic transfers. But in a nutshell, what Globus does, you tell it you want to transfer things from point A to point B, and it sets up a third-party transfer. So it does the transfer for you without your compute node or your login node, wherever you are, your website being the party that the data is going through. It makes it go straight between the two places you want to transfer. If something bad happens along the way, something's disconnected, maybe some data gets corrupted, it'll just restart it and keep going. It's kind of resilient in that way. And importantly, once the data gets to your remote site, it checksums it and makes sure that it matches. So you get some safety to make sure that your data really is complete when it gets there. And under the covers, it uses something called Grid FTP to do fast transfers. So Grid FTP is a service that runs on the compute facilities that can use many processes simultaneously to read a file to send them over the network, so you can get a lot more bandwidth than doing a copy yourself. And the other big thing that it does, aside from the sort of the mechanics of the transfer, is it spans authentication systems for you. So as you've become acquainted with this week, I'm sure, we don't have unified logins across all the facilities for a variety of reasons. But if you have an account at one place and an account at another, Globus will span it for you, can handle the authentication on both sides. So like HPSS, all the facilities have documentation on how to use Globus. And the easiest way to do it, if you want to try it out, I recommend going to www.globus.org. And you can log in a few different ways. You can use a facility account, ALCF accounts and NERSC accounts work just fine. You can even log in with a Google account if you don't have those things or you just want to link it to something else. And once you've logged in, however you're going to log in, you can connect multiple accounts together. So I gave a screenshot from my account. I've got my Argonne account, which is my main identity on here, but I linked it to a Google account and I linked it to a NERSC account. And what that means, especially the NERSC one, it means that I can copy files between NERSC and Argonne and it'll use the proper authentication methods on both ends. So this is what it looks like if you go to globus.org and try to set up a transfer. They have a nice GUI that has a left and a right side. That's the two sites that you want to connect. Up here at the top, it says endpoint. That's blank when you first log in, but this is where you tell it what are the two sites that you want to connect to. So you can just go up into that field and start typing, and it'll give you a list of matches that you can select as your endpoints. If you pick an ALCF one, for example, it's going to prompt you for your crypto card token. So you can put in your authentication method for that, or whatever is appropriate for the thing that you're using. But once you've chosen two endpoints, it'll look familiar to anyone that's used Windows drag and drop or whatever. You can highlight the files that you want, use those arrows up there at the top to just move it. And once you've started a transfer of a directory or some files, you don't have to stay logged in. It'll email you when it's done because you can use this for gigantic files. If you have the space, you can move terabytes of data back and forth. And that's kind of it for Globus. I already spoke ahead of this. The other thing is if you want to pull data from one of these sites to your laptop or vice versa, you can do that too. On the globus.org website, there's a link on there to install what they call a transfer agent. You can click on that, it's optional, but if you install a transfer agent, that gives you the capability to move things to and from your laptop too. And they have agents that work for different operating systems, so you don't have to be running Linux or anything like that. And I don't have an example of this, but you can publish data sets also. So if you have a big project and it's always going to be producing data and you always want people to be able to find it, you can set up a kind of persistent name on Globus. And you might want to check with your facility or your organization to see if they have kind of an account for this already, because like Quincy said with the HTF group, programmers don't eat air. They do charge for some things, and this is one of them. And the thing I wanted to point out, there's if you go to the hands-on exercise repository, this is the same one that Rob used for his array and parallel net CDF examples. There's a Globus example in there too that just gives you a task of finding some files at a particular endpoint that anyone can access and transferring it, and there's a secret message you can decode. So if someone can come tell me what the secret message is tonight, I will know that you've done a great job and you will win a pat on the back. So that's kind of it for the data management tools. We didn't spend a lot of time here because honestly, these guys, HPSS and Globus, have done a great job of making these things easy to use. So I think you can go learn how to do it without us digging into the nitty-gritty.